Good afternoon, all. It is time to welcome the gathering to our second workshop on spatial data analysis and mapping with SuperMap. To continue the session on spatial data processing and 2D mapping, I would like to invite Mr. Jason, the Technical Manager of SuperMap International Asia and Oceania Center. Let me introduce Mr. Jason. Mr. Jason is a professional in geographic information systems and extensive experience in the industry solution and the development of GIS platform. He owns rich experiences in land resources management, disaster management, search and rescue, smart city, and other industries. Sir, it's over to you.
Hello. Hello, everyone. Can you hear me? Okay. So this afternoon, it's my glad to be here to continue our course about SuperMap mapping and spatial analysis, and to share the GIS technology with all of you. And you are all very welcome to join us. So today we will continue from the Monday, which on the Monday we already downloaded the SuperMap I desktop and installed it in our PC, and also we already configured the license. So today our content will be the spatial data processing. Our content will be the spatial data processing and mapping. Okay. I think now you can already see my screen, and the first topic for today is the data structure and the basic concept of SuperMap I desktop. So the first one is data structure. In SuperMap, we manage the spatial data following this structure. The most basic unit is workspace, and workspace can store all of the data, all of our work in the SuperMap I desktop. And also workspace is a basic unit for us to publish our spatial data and GIS capability to web later. So in the future, when we want to use like SuperMap I server or other software to publish our spatial data, we need to choose the workspace. So the workspace is the most basic unit for in this data structure. And inside of workspace, we have the data source, maps, layouts, scenes, and resources. I will introduce them to you one by one. Yeah, and the data set is inside of data source, and others are saved in the workspace. You can see from this workspace manager, the root level is the workspace, and then the data source, the map, layout, signs, diagrams, model, resource, and inside of the data source, we have the data set inside. Yeah. So first, the workspace is used to save the work environment, including the opened data sources, saved maps, layouts, resources, and 3D scenes. And the workspace has two formats. The first one is SXW and the second one is SMW. The differences between these two formats is the SXW is following the .xml structure, and SMW is following is in the binary format. But both of them can work work together. Sorry, both of them can work well in to be a workspace. And then that is data source. The data source is composed of multiple types of data sets, and it is the physical storage for spatial data. And there are three types of data source: the file data source, database data source, and web data source. For the file data for the file type, there are two types. The first one is UDB and UDD. There are double files. They work together to become one data source. And for the UDBX, that is a single file, and they are the same. Just in the earlier version, we use the UDB and UDD format, and now we can just use the UDBX format. And for the database type, that means we can store our spatial data inside of the database. The database such as PostgreSQL, Oracle, MySQL, and others. So that means for this kind of relationship database, we can, based on Supermap SDX plus spatial data engine, to store our spatial data into the database. And inside of data source, there will be some data sites such as vector data sites, raster data sites, and others. So first, that is the data source type. As I mentioned, there are three types: the file, database, and web. For the file data source, we have the UDB, UDD, and UDBX format. And for the database data source, here I listed all of the database we supported, such as the SQL Plus. This one is mainly for the SQL Server, and Oracle Plus, Oracle Spatial, MySQL, PostgreSQL, PostGIS, PolarDB, Genus, DB2, MongoDB, GISDB 200, DM Plus, which is Diamond Plus, and HiGoDB, SignalDB, Kingbase, BeyondDB, KDB, Turbo. So there are so many different types of database. And we can say that for almost all of the common used database in the world can be supported by Supermap. So that means we can easily store our spatial data into this kind of database. And for the web data source, there are some, like we can open the OGC service and open the iServer REST service, and also like we can open the Google Map or World Terrain or OpenStreetMap in iDesktop directly. And inside of data source, there are multiple data sets. For data set, the definition of dataset is a dataset is a collection of data of the same type. The type is the is a type of data itself, such as point type, line type, region type, and also the text, tabular, network, CAD, JOT, image, grid, and so on. So, and the data sets are stored inside of data source. And this data source can be database data source or file data source. There are some of the types of data sets. We can see like the point, line, region, text, CAD, tabular, and vector collection. And also for 3D, like 3D points, 3D lines, 3D region, and model data sets. And there are some like raster. For raster, we have grid, image, mosaic. So these are different types of data sets. We will take a look at detail for them later. And then it's layers. A layer is the display media of a data set. And a layer helps display the object in a data set with appropriate styles in the map window. And a map consists one or more layers. We can think that the relationship between the dataset and layer is every layer has they have a corresponding dataset, but one dataset can provide multiple layers. You will take a look at them later, and multiple layers combine to a map. A map is composed of one or multiple 2D data sets with specified display style. And we can say in the workspace management, we can see a lot of data sites. And for one data site, every data site has a corresponding style, and it should be a layer in a map. And different layer, multiple layers combined into maps. So this is the relationship between the data sites, layers, and maps. And then the layout. A layout is composed of one or multiple configured maps, as well as some mapping elements such as the map name, legend, map scale, etc. And the storage type of layout is physically stored in a file or or database via the workspace. So the layout is also one of the parts of workspace. And next is the resources. The resources are a collection of symbol libraries used in the maps and scenes. And resource libraries contain marker, line, and field symbol libraries. We can see inside of the resources, we can find the marker symbol library, line symbol library, file symbol library. And when the data site rendering with some style in a map, and those style is provided by the resource. Okay, and then it's 3D scene. A 3D scene actually is very easy to understand. It's a 3D corresponding 3D of like 2D map. It's a 3D map. And a 3D scene enables the loading of 2D and 3D point, line, region, text, image, grid, model data. And the 3D scene realize the 2D and 3D integrated display and management. So the storage type of 3D scene, it is also stored inside of the workspace. Okay, now let's take a look at the data site in detail, because the data site is the minimum unit for spatial data. First, for the GIS data, there are different the data source, like the map data from paper map, and the remote sensing image data, the field serving data such as from GNSS like GPS, and digital data such as the data from statistical yearbook or from the text report. And when we want to and the first method for us to operate with dataset is we can create a new dataset. And when we want to create a new dataset, we can choose the type we want to create, and also we can set the attribute table for it. So yeah, there is a demo, but I will show you. For them later. Okay, and this is to show a database, data source, and others. And next is and the second topic for today is the data importing. For Supermap at desktop, there are a lot of data types or data formats we can support to import to at desktop, such as for the vector data, we support to import the data from CAD, from the GIS general formats such as shape, and from the tabular such as CSV or Excel or even text format. And for raster data, we support the general image formats like JPG, PNG, TIFF, and also the compression format such as SIT. So for the vector data, we support to import them to the data source. And for raster data, we're supposed to import them, or we can open them directly. And here is it listed all of the supported formats. We can find most of the common used data formats of, spatial data are listed here. Some common used such as the grid data, the DBF, and also the shape data, for the raster like VRT, or like the TIFF, the GIF, IMG. For all of those we can support. Okay, and after import the data, the first thing we need to consider is about the coordinate system, because GIS system is pretty different with others, such as with CAD. For CAD, there is only one planar coordinate system. That means the coordinates in the CAD software has no real geographical meaning. But in GIS software, we have to consider every feature, every coordinate should have a real meaning in the real world. They should have a real coordinate. They should have the geographical meaning. So the coordinate system is the first thing we need to consider. And there are at this top, there are more than 1,000 predefined coordinate system inside of IDESktop. And besides of it, you can also create one by yourself. You can also create your own coordinate system by yourself. I'm sorry, please do not draw the lines on the screen, okay? Yeah, let me erase them. All right, and let's continue. So for talking about the coordinate system, we need to know the type of it. There are three types of coordinate system. They are planar coordinate system. That means, and for the planar coordinate system, it's only defined by the unit, like the km, dm, cm, mm, and others. And the planar coordinate system means it's similar with the CAD software, and it has no geographical meaning. And next, these two are geographic coordinate system and projected coordinate system. For the geographic coordinate system, the unit of them always be screen. It should be screen. It should be degree. And we use longitude and latitude to show the position or location for the point or for the object by using this coordinate system. And projected coordinate system is the unit of it is always like meter, and that is a projected. That is from a ball of Earth, and like we find some light source to project the Earth to a planar paper, and the method is different than the projected coordinate system is different. So these three are different types, three types of coordinate system. And for the project setting, we can right-click on the data site and then choose properties, then coordinates to set the coordinates. Okay, and also in IDESktop, it supports the dynamic projection. That means if you want to put two or more data sets in different coordinate systems together and show them together in a map, so you just need to check this checkbox, the dynamic projection. You just need to check it. Okay. And besides of the dynamic projection, sometimes we also need to do the projection transformation. And that is if we want to put two or more data sets in different coordinate system together, and we want to modify them, we want to transform them from one projection to another projection. And the projection transformation will change the coordinate value of features inside of this data. For example, if we want to if the source coordinate system is the WGS 1984, and we want to transform it to sphere Mercator, and earlier the unit of coordinates here is degree, and after the transformation, the unit of the result will be meter. And as we know, the degree should be in the range of minus 108 to 108. And but if we transform it to a sphere Mercator, the value of this number will be pretty big because the unit is meter. So it will change the value, change the number of it. But if you wrongly choose the reset, not the transformation, then the reset will only change the projection information stored in the software, but it won't change the actual actual value. Okay, so and here there is also one projection transformation. I will show you later. And next is after we import our data, and we need to consider about the coordinate system, and also sometimes if we have the data from the paper map, such as I have a lot of paper map and I want to digitize them. I want to do the digitization. So we can use the registration function to do the to import it and give them the geographical meaning. And there are two methods. The first one is if we have the registration data and we have the reference data, such as we can see the point one, the point 1.1, point 2, point 2, point 3, point 3, and point 4, point 4. There are four group of corresponding points in the reference layer and registration layer. If we have the reference layer, we can just pick the point from the paper map we scanned, and from the reference data. And the method two is if we know the real coordinates of this point directly, so we can import it directly. And this is the registration data and reference point table. So, and for this one, we just need to set the reference layer and then input. And then if we get the coordinates, we can import it to do the registration. And yeah, and it's like this for the source point and source Y, we can choose from here. And for the target point and X and Y, we can just input it. So this demo I will show you, and also I will show you this with earlier all of them. Okay, so I will show you about this demo. So first, let's take a look at here. Okay, sorry, let me find. Let me find the data first. Where I go to? I will find it from. Sorry, I need to find it from the folder. Okay, so we can see there are some data, And first, there is a JPG file. And this picture is the paper map we scanned. We use a scanner to scan the paper map and to get it like this. And also we can see in the corner, there are some pinpoints such as this cross, and it has the coordinates. And also here we have a cross there, and another one. Yeah, and every corner there is a cross. So for this picture, now it is only a normal picture. If we want to we want to make it as a digital map, we need to do the registration, right? And there is a UDB and UDD, the UDB and UDD format. As I explained, the UDB and UDD is the format of data source. And there is some other texture. I will introduce them to you later. Okay. So first, we can use our iDesktop. We can open the iDesktop and then choose in the data source. We can right click and choose Open File Data Source, and find our digitization UDB. This is our digitization UDB. And inside of this data source, there is one point data set. The point data set name is the reference point. We can see in the reference point, there are only 4 points, right? There are only 4 points. So we have the reference point for the picture, and every point is corresponding to the corner. Okay, so first we need to import this picture to the iDesktop. So we can right click at the name of our data source and then choose import dataset. Import dataset. Okay, then click add file. And then find this folder. Okay. Find the folder and choose this JPG. And we import it as an image data. Then click OK, import. And now we can see there is a new data set named as New Haven 1984. And if we right click and choose the properties and then choose the coordinates, we can see now it is in a planar coordinate system meter, and the unit is meter, and it's no projection parameter. That means this picture cannot be added to the Earth now. But for the reference point, if we choose it and see the coordinates, then we can see the coordinate name is the UTM zone 18 north, and the ETSG code is 26718, and there are a lot of coordinate system information. So next, if we want to give this picture a real geographical meaning, so we need to do the registration. All right. So we can, in the Start tab, we can find the registration and then choose the new registration. And the first one, the registration data should be the New Haven, because we want to register it, right? And click next. The reference data, we can add the reference point as the reference data. Then click finish. And now we can see the screen has been divided into 2 parts. The left part is the registration layer, and the right part is the reference layer, right? Okay, so we just need to need to pick the point, such as this cross corresponding to this point 1. And in this corner, the cross is corresponding to this point. and it's the same for the third one. For the third one, this point, okay, that's point 3, and then the point 4. Yeah, this is a point 4. And in the bottom information box, we can see there are already 4 points, and every point has a source point at source and has a coordinates of source point and target point. So the source point is the coordinates of this point in the registration layer, and target point is the coordinates of this point in the reference layer. Okay, after that, actually, it's very easy. We just need to choose the algorithm. Like we use the linear or polynomial or rectangular or just the offset, and different algorithm for registration needs the different minimum points. Like the linear needs 4 at least, and others are different. So we just need to use linear and to click calculate error. Then in this information box, we can see the residual x, residual y, and RMSE already been filled. Okay, so this is the offset or the error for these 4 points. Then we can click registration and just set the result name, such as this name can be New Haven 84 adjust. Yeah, we just use the default name and click OK. All right, so now we can see it's already finished, and inside of our data source, there is a new data set named as New Haven Net 84 adjust. And if we double click to open it and just to create the image parameter to write the speech. And then we can see this picture become to like this. And but for this data, if we check the coordinates, then this picture will be in the coordinates name. It will be in this coordinate system, and every point in the picture has its own geographical meaning. That means every point can find the corresponding point in the real world. So this is about the registration. All right, let's go back to our PowerPoint. Okay, and after and just now we talked about 2 methods of importing data, 2 methods of getting data. Like the first method is we can import from other formats, and the second one is if we get the data from the paper map, then we can do the registration to process it. And next is how to do the data processing or the data editing. First, we can draw the feature. Like the application provides the feature of drawing and editing objects. Draw objects function includes point, line, region, and text object drawing. Different methods are available for drawing different objects. Such as I will also based on the iDesktop to show you. And if based on this paper map, and I can use it as a base map, but if I want to suggest the black area on the map is they are the building. So if I want to save the different information, save the information for the building, the attributes for the building. So I need to do the vectorization first. So First, we can in the data source, we can right click to create a new data set. Right click and then choose new data set. Then in the type, we can choose region, and the name we can set it as building, right? Yes, and then for this data, for this is an empty data set. We just created it. But for this one, the first thing is we need to set the coordinate system. Yeah, and because we can see now it has no projection parameter, and we can use like this button to copy the coordinate system from other data sets like this, and then we can right click, add to current map, or we can drag it to current map. And we can see there are 4 points on the layer. The first one means visibility, and the second one means the first is visible, and the second one is selectable, and the third one is editable, then it's snappable. So if I click this gray pencil, it will be light, and then now I can draw the feature, draw the building on the map. In the object operation and then the region, there are different methods for us to draw a new region. So I just use the default one and draw like this building, such as maybe this one. I will do the vectorization and following the boundary to draw a building. Like this. So now I already draw a building. Yeah, and for this building, if I click it, then on the right side, we can see the attributes, such as the ID, the bounds, and the area parameter, geometry size, and geoposition, like this basic information. The gray one means they are the system fields. And for this one, if we want to add more fields for it, we can right click, then choose properties, and then we can choose the attribute table here. In the attribute table, the name with a star means it's the default system field. We cannot edit it, but we can add some new one, such as here, and I can give it a new, such as a name. Sorry, such as a building name, right? And the type of this building name should be text, then click apply. And also the owner, okay, and click apply. Then when I click this building again, we can see there is a building name and owner. Then we can import it, such as the owner is Jason, and the building name is like the big building. All right. So we can through this way to modify the information for the building. And there is another way to draw a vector easier, which is we can see there is a vectorized region, and in the setting that is based on the color to extract the feature directly. For example, I just click this button and then just click once, then one building will be drawn. I click once, so it will be more easier for us to extract every building like this, and also, and after that we can based on it to, such as this one, to input the attributes for every of them. And at the same time, if we right click and choose right click at the data set and choose browse attribute table, then we can see there are 3 fields here. And because we already hide the system field. And if we show all of them, then this is the attribute table for this data set. Okay, now let's go back to the PowerPoint, and that is the vectorization. And then for the vector data, always we need to based on it to do the vector data processing, such as dissolve, append rows, moves, or append column, attribute update. So in iDesktop, there are a lot of functions provided for you to do the data conversion. Yeah, but for today, I think I won't show all of them to you one by one because there are so many tools. But for everyone, it's very easy they are all very easy to be understand. So if you have needs, you can find from them. You can find them from here. Okay, and next is the symbolization, which is to make a map. Such as the 2D map has the 2D map, for one 2D map, it has two types of layers. The first layer is general layer, and the second layer is the thematic layers. For the general layer, it's very easy. We just based on a style to show our data and to set a style for it. But for thematic layer, that means different objects shows in different style, but they are all in the same layer. I will show you later. So for the general layer, if we want to set the layer style, we just need to right click and then choose this layer in the layer manager and then choose layer style. Then we can find the style for it. And after that, we can save the map and workspace. Then your mapping work will be saved. And for thematic map or for thematic layer, there are different types of thematic layer, such as the unique value map. That means based on the one field and different value shows different style. And ranges map, label matrix map, or graph map, graduated symbols map, and dot density map. There are different types, a lot of types of thematic map there. And how to do it? First, the method one is we can select the layer and go to the thematic map and choose the thematic map tab. And the second one is we can right click, select layer and right click, and then create thematic map to find a suitable way, we want. Okay, so yeah, and there is another demo to create thematic map. I will show you later. And there are different information. There are information for the different types of thematic map. First, that is the unique value map. That means we based on one expression, and this expression can be a field or a field with or more than one field, but there will be a value. If the value is the same, then we will render the object in the same style. If they are in different value, then they will in different style. So that is the unique value map. And next is the label map. It's very easy to be understand. That is based on the object to render a label. Okay, and the last content for the PowerPoint is the map layout and other is the map layout and output. Suggest there is a map layout and printing. The map layout is after we based on our data to create a map, then to make our map more beautiful, professional, and readable, we can adopt different map layouts and add various elements according to the map type. And for printing, that is for further use. a map can be exported as an image or a PDF file, or printed out directly. And for the map layout, based on the layout window, we can edit any element visually in a layout, assign and place various contents such as maps, legends, scales, text, and so on. We can see from this layout, there are the title and then the overview map, the ruler line, and also the legend and the scale. And this one is a scale bar and the compass, and in the center it is a map, and also we have the frame. So all of them combine into a layout. And for legend, we can we generate a legend based on a map to help us understand the meaning of each map feature, and modify the properties of a legend to make it fit the map theme information much better. And the overview map is actually it is at another map, and the overview map in a layout to view the position of a map in a larger area, and we need to add a map illustration to reach the content of a map layout content and to make a map layout more reasonable. Okay, and in a desktop, there are 27 default layout templates, including the universal and land use planning templates are provided. And the predefined formats are saved in layout templates, which is convenient for the creation and reusing of standardized layout. And after we make the layout, if we want to output it, we can output the map as the image or a PDF file, and then we can print it directly. So this will be the whole process for us, from import a data to data processing, to make a map, and to make a layout and output the layout. This is the whole progress. So, okay, I think based on the time, we can take 10 minutes left. We take a 10 minutes break. After that, I will show you based on the desktop, where you can download the spatial data, and what you need to do to create our own map, and how to create a layout. And I will show you by the operation based on the desktop. Okay, so let's take a 10 minutes break. See you later. All right, hello everyone. Let's continue. Okay, so on the first half of today's course, let's take a review of it. So first, we talked about the data structure in the SuperMap desktop, and the second one, we talk about the data importing, such as from the vector data and from the raster data. If we import from the paper map, scanned paper map, we need to do the registration, and also we introduced the coordinate system, and how to draw a feature, and how to set the style, and how to make the map, and how to make a layout. So today and now, I will show you from the beginning, how can we create our own map? All right, first of all, we need to download here. I'm sorry, here I will create a new PowerPoint, and record the step here. So the first one is download the spatial data for your country. Yeah, I know that all of us are coming from the different country. So here I prepared two website for you, to download the free spatial data, which are, let me open them. Okay, yeah. Now we can see there are two websites. So the first, yeah, and I will also put them. I will also put the link to here, and the second one is this one. So there are two datasets. There are two websites. The first one is divagis.org, and in the divagis.org, we can choose. We can say this is a free computer program for mapping and geographic data analysis, and we can get the free provide we can get the free spatial data in country level. And if we click the country level data, then in the country we can easily find almost all of the country here. And today I will use Sri Lanka as a sample. So if we choose the Sri Lanka, and then in the subject we can find, like, we want to download the administrative area or inland water, roads, railroads, elevation, and land cover population, gazetteer, and other data. So for those, you can choose to download them. And this time I already download the administrative area, inland water, roads, railways, railroads, and elevation data here in my data Sri Lanka here. And we can say the administrator, this is the administrative area, the elevation, the roads, the railway roads, and the water. So if we open all of them, we can say they are all in the shape file as HP file. And the administrative has three levels: the admin 0, admin 1, and admin 2. But for others, like the roads, there is only one shape file. Yeah, so this is the first website we can download. And yeah, I will also share the link to all the to the Zoom. And the second link is the geofabric.de. And for this data, actually, that is for us to download the OpenStreetMap data exchange. We can download the free OpenStreetMap data from this website. It's very easy, and we just need to choose the region first. For example, if we choose Asia, and then we can find the sub-region in the Asia. So today we can choose, we can find the Sri Lanka from here, and we can click the .ship.zip to download the shape file directly. Okay, and just now I also already downloaded, which is here, the Sri Lanka latest free.ship.zip. And after I unzipped it, we can see there are a lot of shape files, including the building. We can see the building and land use area, the natural area, and natural points. and the places area, the places point, and the POI, the railway, the traffic, the road, the transport, the water, and the waterway. So we can say they are all this data is pretty detailed than the earlier. Okay, so after we got them, what we need to do? First, let me close the earlier workspace and in the and here. Okay, and here first we can right click and then create a new file data source. Create a new file data source. Name it as SLK1. Yeah, I will give it a name as Sri Lanka 1. So and then right click at the name of this data source, then click import dataset. Click import dataset. And in this panel, the first button is add file. The first button is add file, and we can click it. Then to find the data we want to import, for the shape file, we only need to choose the format of .shp. We only need to choose this one. So for this shape file, we choose the admin 0, admin 1, and admin 2. 0, 1, and 2. I choose all of them, then click open. Then in the table, we can see there are 3 shape files. It's the same if we want to import them in one time. So we just need to choose all of the, like the road, the railway road, and also the water. And for the water, there are 2. The first one is water area and water line. Okay, I press Control to choose multiple items in the folder. All right, and of course there is elevation data. Elevation, or we can call it as a DEM. For the DEM data, it's not in the shape format, but we can import the VRT. This one, the VRT format. Okay, so for others, we choose them. When we choose them, we can see there are some parameter we can set. But for the shape file, we just need to keep all of them as default. For the elevation data, we need to change the tab from image to raster. Yeah, because this is a DEM data, it should be a grid. It should be grid. So we import it as the raster data. Then click import. Based on the data volume, it will take the time like longer or more quick. Okay, so now we can see inside of our data source, there are already some data sets like admin 0, 1, 2. And if we check the attributes for them and see the coordinates, we can see the coordinates of those shape file, they are all WGS 1984, which is the most common used coordinate system. And the EPSG code is 4326. Okay, and if we check the attribute table, such as we right click at the admin 1 and browse attribute table and hide the system fields, we can see there are some attribute table, such as the name, and the admin 1 is I think it is the name or the district of Sri Lanka, or the province of the province maybe, and in the name 0, they all belong to Sri Lanka, and in the name 1, it's the name of every province. Then the type and the English type, they're all district. And let's take a look at the admin 2. We can see the name 0, they are all Sri Lanka, and name 1, they belong to which district, and name 2 is the name of every division, and the type of them is the division, right? Okay, and there are some of them has some other name. Some of them have other name. All right, so these are the shape file. If we double click them, like I double click this one, then it shows this data. It shows the admin 0, and this is the boundary of Sri Lanka, of whole Sri Lanka. And if I add the admin 1 here, we can see there are different polygon, and every polygon is one district or one province in Sri Lanka. And the admin 2, we can, if we drag it here, we can see all of them like this. All of them has its own attributes information, and they have their own division. And if we take a look at the rows, we drag it here and set others as invisible. We can see it only at the main rows of Sri Lanka. And if we browse the attribute table, we can see it shows the description, the class of the road, and like the secondary road or the annual, or I think also have the primary road. All right, and if we add the railway, so this is the railway in Sri Lanka, and the water, and this is the and this is the inland water, and this is the rivers. These are the rivers. So we can see most of them, the rivers and the water area, they are connected with each other. So that means the data is correct, right? Okay. And another one is the elevation data. If I double click to open it in a new map, it shows like this. And the color is more red, means it is more high. And it's the same if we add it to the new spherical scene, if we add it to a 3D scene. And when we go through it, we can see, yeah, we can see the terrain. We can see the terrain provided by this DEM. Yeah, it's like this. Yeah, so about 3D, we will discuss the detail of them on next Monday in the next course. Today, we will mainly discuss about the 2D. All right, so based on this data, and there is another data which come from the OSM. We can say from here, come from the OSM, and this data is pretty detailed. It will take us a few minutes to import it. So in order to save our time, I already created another data source, and I already created a data source, and for us to import, which is this one, the SLK OSM data source. So here I will just open it directly, the OSM data. Okay, and what's inside in the OSM data? Let's take a look. First, it is a building. And because this building is pretty big, we can see there are more than 200. There are more than 2 million buildings. So if we just open it here, and every building is very small. So if we just open it, we cannot see them. But if we suggest from here, if we add it to this layer, and then go to the detail of the map, we can see those are all the buildings, and every building has the information of ID, code, class, and name and type. Some of building have the name. So So we can get a lot of building information for Sri Lanka, and it's pretty it's pretty big. The data is pretty complex, right? And the second one is the land use data. We can, if I open it here, yeah, jog it here, we can see, I mean, set other as invisible. Yeah, we can say these are the land use data. So for land use data, we can say they have the one attribute, which is the F class. And for the F class, we can take a look. There are different type. It shows different type of land use, such as they are park or residential or the like quarry or forest or others like cemetery or military or industrial data. And also this data volume is pretty big, more than 36,000. Yeah, it's not that as much as the building, but they are also big. Okay, so and for others, I think if you have time, you can take a look at them one by one. So today, now we are going to, based on those data, to make the map, to create the map. The first map I want to create is the administrative map. So in order to create the administrative map, first I need to, based on the admin one, to show the bounds, to show the boundary of every district in Sri Lanka. So for this one, because for the administrative map, always for every province, they will be shown in different color. That will be better, right? So we can right click at this layer and then choose create thematic map, and then we can find the unique value map and default, click OK. What's wrong with it? Let me try again. Oh yeah, it shows correct now. All right, and now we can see there are two layers. They are all corresponding to the one data source. They are all corresponding to one data source. And in the right side, we can see this is the panel of thematic mapping. Then in the expression, we can choose, we based on the which field to create the thematic map. And for example, if we use the SMID, then every feature has one ID. So that means every feature they will based on the different color. And we can also choose the color scheme here. For example, we want this style of map, or we want it to be more colorful like this, or we want it to more like green or blue style. And also for we can choose we can customize it. We can set the color scheme one by one by ourselves. Okay, so for this one, I will choose just use the default one. And so this is the style for the thematic map. And then I want to add the name of them. So it's the same with create the unique value. Right click at this layer and choose create thematic map, and then choose the label map. Choose the label map. For the label, we need to find the style, like the uniform, then click OK. All right, and the expression, the default expression is a field of name 0. we want to show the name of every district, we need to choose it to the name one. So it's like this now, right? So now every layer, every district shows different color, and they all have their name. And next, I want to show the detail inside of every district. So which is in the admin 2. I dropped it here. And for this layer, it will be more detailed. So in this way, we will do it when we will do it like when we zoom in, the layer will switch to more detail, right? So suggest when I zoom into this level, and I want to achieve that if I zoom in again, then it will show me the more detail. So for this two layer, I can set the visible scale. Suggest we can set the current scale as min scale or set the current scale as max scale. If we set it as min scale, that means if we zoom in, if we zoom out, then this layer will be invisible. And if we zoom in, this will be shown. So I need to set this as the max scale. Clear first, and set it as max scale, and also set it as max scale. But for the more detailed one, like this one, we can right click. We also need to right click, create the thematic map, and show them in different color. And also I want to, based on it, to show the label map, to show the label of every district, which is label 2, which is name 2, right? Okay, so and for this one, for this 2, we can set it as the min scale. Set it as min scale. This one is the same. Okay, so now what we can achieve is, if I zoom out, the map will go back to the district, right? Like this. And if I zoom in, then it will go to a more detailed map. It will go to a more detailed map. But I want to achieve like if when I zoom in, I also want to show the boundary of district, show the boundary of province. So for this one, here actually I can set the style of the big area, like choose the layer style, and then in the styles I choose it as none, and then the none means the field is not, and the line style I choose as the dash, okay, and the color is red, the width is maybe 1. Okay, now we can see if we and we need to put it upper than the, which is like this. Yeah, so it shows like this. And this we also need to set as min scale. Yeah, so now what we can achieve is, if we just show a small map in a big scale, then in the small scale, then we can say this shows the district. But if we zoom in again, then it shows like this, and the boundary of district is shown in a red color, and every small sub district has been shown and has its color. So this is one method for us to create to control the visibility of administrative map. And based on it, we can add more detail, such as for the roads or for others. for example, if I want to show the buildings here, like the building, I draw all of the building directly, and it seems this is a big city. But if we show the building, if we show all of the building directly, it will be very massive, right? So so we can also set the mean visible scale for the building, like when we want to show the building here. So we can set visible scale and then set it as mean scale. So if we zoom out, then there is no building, and if we zoom in, the building will be shown. And also for the building, I want to set the style of it, such as set a color. So yeah, this color and the line. I don't need the line. Oh, sorry, there should be a line. Yeah, this will be better. Maybe just this color. This will be better. And for others, it's the same. If we zoom in, oh, there's no building. Yeah, just like this. And also for the road, we can also add it to the map. And if after we add the road will be better. The map will be shown better, right? And for the road, we can see the attribute table. There are different class for the road. They are some of them are trunk, or some of them are secondary, or residential, and others. So for the road, if you are interested at it, and if you want to add the road as one of the elements to your map, so you can add the road and also right click, like create the thematic map to create a unique value. Then the expression you can choose as F class, right? You can choose as F class. And for those different type, for example, like for the past trunk, yeah, for the trunk, you can set the style for them one by one. For example, if I choose the trunk and use the national road style, then we can say the trunk, it will be shown as a national road style. And for the trunk link and track grid in different grid, now as a default one, they are all in different color. And but when you check it, when you double click, you can set the style of them. Okay, and it's the same like the railway. Yeah, the railway. This is the railway, and if I want to change the style of railway, I can find the railway like this. So, but we can say if we show all of the data like this, it will be too massive. So for now, from my side, I won't add the roads, the detailed roads for OpenStreetMap. I will just add the main road like this. But this road is still massive, right? So how about show the road in this level, and put it here. Show the road in this level, and when I zoom out, it's only, yeah, the railway also set the railway is the same. Set this scale as the mean scale. Okay, so now it will be like this. it will be like this. If we zoom in, it will show the railway and the main road, and also if we zoom in continually, zoom in, we can see the building here. All right, so this is only one example to create administrative map. And there are still a lot of different elements for us to choose to add them to map, such as for the POI, we can take a look at the POI attribute table. And in the class, such as the school, the supermarket, and the embassy, and like a hospital, the guest house, a lot of different types of POI for us to add them as a map. So we can, based on those functions, to create a map similar to like Google Map or OpenStreetMap. It's all up to you. All right, for this map, I will save it first. Yes, and save it as Sri Lanka administrative map. Okay, so this is a Sri Lanka admin. And the second map I want to create is the land use map, the land use data. So for the land use data, I want to based on the elevation, and then add the land use area to this map. So for the raster data, this one we can also set the color table. For example, this is the default one, but I want it to be more like just like green. So this will look more easier or look better for us. The color is more more dark, means it's more high. Sorry, I still think the default one is better. And based on it, if we want to add the land use, maybe if we just use the admin as the base map, it will be better for us to create the land use data, right? Yeah, because it has a lot of color. And for the land use, it's the same. We can also create the thematic map and just choose the unique value. We can use the unique value map to achieve a lot of function. And for the expression, we need to choose the F class, right? The F class. And for the F class, for the color, we better find the suitable color for different types, such as for the forest. I think the forest should be dark green. The forest should be dark green, right? And such as for the park, it should be the light green. And yeah, for the farmland, personally, I think this color will be better. This color will be good. Okay, and we can say this is one of the detail. And for the detail, you can see the middle or some other like a group. So you can set the suitable color for all of them. All right. So this is to set the color. And if you want to set the style for all of them, here you can choose all of the layer like this, and find the second button, which is styles, and you can see which parameter you want to modify. It's a line or line white or line color. And for the fill style, you want to set the fill symbol or like the background or others. So for the line, I click the line and click next, then choose the none, because I think for them, there should if there is no line will be better. If there is no line style, oh, it's here. The symbol, choose 9, click OK. Yeah, now it looks like this. It will look like this because there is no the boundary line for the land use. And for this data, if we want to create, we can just put it like this to make it as the land use data. So I just close it and save it as Sri Lanka land use. Okay, and another map I want to create. It's very simple. It is the terrain data. It is a terrain. So just with this layer, and close it to show Sri Lanka terrain. All right. And now we can see, based on those data, I already create the administrative and the land use data, the land use map, and also the terrain map, right? So based on them, we can do some, we can create some layout, such as for creating the layout, we can right click at the layout and choose new layout. In the new layout, as I mentioned, there are a lot of templates for us to create the layout. So how about if I choose the multi-map with diagram like this, create. So yeah, for example, this is the template of our layout, and for the title, we gave it a title as Sri Lanka map, just like this. And and the font, we can set it as Arial, the size as 30, and bold. Okay, this is the title of our map. And for the first map, I want to add it as the administrator, right? And the second one, I want to add it as the land use data, the land use map. If we want to change the position of the map, when we choose this map object, we can see there is a Fox map, and click it, then we can easily to modify the map inside of layout. For example, I will just show the detail of it. Okay, and for the third, and then click it back. And for the third map here, I will show it with a terrain, right? And also I need to focus on it to show the terrain of Sri Lanka like this. Okay, and next for the chart, I don't want to put a lot of legend for it, because like for this one, it already has a label, because the legend is pretty pretty easy. So I will just delete this and put it back. Okay, and for this legend, I don't need it. For this legend, I don't need it. And for the chart, I also want to delete all of them, because I want to add the land use legend. I want to add the land use legend, because the land use legend is pretty complex. All right, so we can choose this map, and in the object operation, find the legend, click it, and then draw a polygon, then to create a legend like this. And in this layer, and in the legend, we can set the title such as like this one, land use legend. Okay, and for the columns, it shows the columns of legend for like how many columns you want. And for the item visibility, we only need to show the thematic map legend. So it will be shown like this. All right, and there are some other text information such as this, like made by Jason, right? And the date is 2021 July 29th. All right, so this is one example of our layout based on the map to create the layout. And on your side, if you want to, based on this data or other data you already have it by your own to create a map, I think the first point for you is to consider about the topic, because every map should have a topic, such as these three maps we made. The first one is administrative, and the second one is land use. The third one is the terrain. The map doesn't mean it must be very complex, but it have to show some information to the reader, to the map reader. That's why it's very important for the topic of map. And after we made the layout, we can click here to export to picture, right? Export to picture, and to find it, and to find a folder for it, and click OK. Then this layout will be exported to a picture, which is this one, the layout image. And we can say this will be the final result for us to make the map. Okay, actually, that's all of our today's training. And here I want to take a few minutes to introduce you how to to show you our homework today. So next course will be about the spatial analysis and the 3D. So after today, your homework should be about mapping. And this document is the reference guide, the reference guide for mapping group of the 19th SuperMap GIS contest. And inside of this document, you can see the submission format of this mapping group, and this will be also the homework. It doesn't matter if your map is not very complex. It doesn't matter your map is very simple, but you can just based on the judging standards, like from the data, from the map and performance, and the extra score to judge how good is your map. And also there is a reference process, like from the data preparation, processing, map rendering, and improve browsing experience. And for the submission, you can refer to the format of submission. Okay, and now I will send now I will send this document to I send this document to our Skype group. All right, and also I will share it. I already share it in the in our classroom in the Google Map, which is here mapping results, and this is a performance guide of for mapping group. And at the same time, if you have trouble to connect with the Google Classroom, you can just upload your results, upload your results to any cloud drive and to any cloud drive and send the email to this email, which is zhangqin@supermap.com. Okay, and also I will share this document to the Skype group. All right, that will be the content for today. And I got one question from our Zoom chatting, which is I wanted to know how can I select or create map on one district, not whole country. That's a very, very good question. We can take a look at the administrator, such as here. And there is one function which is very useful, that is the map clip. So if you want to, for example, if you want to make the map, for only one district, such as this one, so you can just select it and then use map clip and choose select object area clip. And after that, you can choose which layer you want to clip. And then if you just select this and the target data set, then you will get the data for only this one polygon. All right. So yeah, it's also okay if you just create the map for this district, because it will be more easier for control, and the data volume won't be so many. All right. If you have any further question, please feel free to raise your question in the Skype group. And that's all for today. Thank you very much. Thank you for your time. Let's discuss on next time, which is next Monday. See you later. Bye bye.